Yay, the interrelationship between hardware and software. Section 9.4.2 of the Software Design and Development syllabus. This is a Death by PowerPoint epic. It's actually got about 14 parts to it, so therefore I'll probably make a whole bunch of different videos for it. Let's start at the beginning. Digital representation of data, or if you like, why computers use zeros and ones. And this one's an important starting point because we need to know why we process binary data. It would be so much easier if we didn't. Anyway, back in the good old days, the first computers, UNIVAC and ENIAC, well, they're the first recognised computers in any modern sense of the term, processed their data using vacuum tubes. Now, a vacuum tube is about 6 inches long, very power hungry and unreliable device. But they were used by these devices to process data. Vacuum tubes still process data in binary form. They were either charged or discharged. Hence, they process data in binary. Now, if we move forward a couple of years to 1947, William Shockley gave his gift to the world, the transistor. A transistor processes binary data as well. It has two states, charged or discharged. And from that, we get all of our computer processing. Just by way of comparison, by the way, I said that a vacuum tube was about 6 inches long and very power hungry. In today's processors, and I'm thinking now about the Xbox Series X, the transistors are 7 nanometers long, or 7 nanometers in size, which is about 70 atoms across. That's really, really, really small. And so therefore on an Xbox Series X, you can fit about 15.3 billion transistors on a CPU die. Now if we compare that to the previous generation of Xbox console, the Xbox One X, it had 6.6 billion transistors on its CPU die. Short version of the story is there's a lot of transistors, very powerful processing, and in one generation of console, it's 1.5 the size or number of transistors. That's an impressive move forward. So every computer, no matter the age, no matter the speed, no matter the operating system, no matter what, whether it be your phone, your watch, your computer, a Linux device, a MacBook, a PC, anything, they all use binary to process data. Therefore, we need to understand it. What does this mean for us? Well, all data is rendered in terms of ones and zeros. So text-based data is ASCII, or one form is ASCII, uses 8 bits to represent English text, and that's an important word there, English. We'll come back to that. We can use anywhere between 1 and 48 bits of data to represent colours in a pixel. Audio and video data represents in both instantaneous and continuous form using ones and zeros. We hear about 16-bit audio or 256 kilobit audio streams as both instantaneous and continuous. Anyway, the short form of that is all data is binary, all of it.